In this video, I will discuss about look ahead carry adder, or also known as carry look ahead adder. So already in my previous video, we have studied about parallel adder, which is also known as cascading full adder, or it is also known as 4-bit triple carry adder. This is the circuit diagram of 4-bit triple carry adder. So in this circuit we can observe that if we are going to add two binary numbers where each number is having 4 bits, for example, suppose this is one number, say this is another number. So to add these two numbers, we can use 4-bit triple carry adder. So here the first bit of first number and first bit of second number, that is LSB of each bit. So initially we'll use one full adder. This bit will be added with this bit along with the carry. At the beginning carry is 0. So it will produce the carry and sum as output. Here the sum output, we'll call it as S0, and it will produces the carry. So in full adder, the sum result will be calculated fast. After that the carry result will be calculated. So here this output carry output of the first full adder acts as carry input for the next full adder. So this second full adder will not produce the sum S1 until it receives the carry from the previous stage. So till it receives the carry from the previous stage, this FA2 full adder will be idle. It doesn't process anything. Similarly, FA3 will not produce the sum output S2 until it receives carry from the C2. So that's why the name is ripple carry. Here the carry will move from one stage to another stage. So it takes time to produce the output. So 4-bit triple carry adder will not produce output immediately. So to avoid this, we prefer using look ahead carry adder, or also known as carry look ahead adder. A carry look ahead adder is a circuit which performs binary addition fastest by using carry generate and carry propagate techniques. CLA, that is nothing but carry look ahead adder circuit, reduces the propagation delay time. So as we seen in this circuit, the carry has to propagate from one stage to another stage. So there will be a delay. So that delay can be avoided by using carry look ahead adder. I will explain how it happens. The carry look ahead adder computes one or more carry outputs before the sum. This is the main point here. So carry look ahead adder computes one or more carry outputs before the sum. That is, in case of carry look ahead adder, all the carries will be calculated before producing the sum. Let me explain that circuit. So this is the full adder using two half adder circuit. So this is the truth table for the same. So here the carry look ahead adder, we have to concentrate only on the carry output. The sum of carry look ahead adder or ripple carry adder is same. It doesn't make any difference in the sum, but it will produce the carry fast. I'll explain how it produces the carry fast. So here let me assume this as AI, another input Pi, and I will assume the present carry input, that is Ci. With comparing this circuit, I can say Cin is nothing but here Ci, and let me call this is carry output Ci1, Ci plus 1. So here Ci is the present input, present carry input, and Ci plus 1 is the next carry input. That is, here Ci is nothing but Cin and C1 is nothing but Ci plus 1. So this is the sum output, that is, I will represent it as Si. So for this circuit, now let me write the carry expression. So here I can write Ci plus 1 is equal to, as we know the output of this is Ai X or Bi, and here the output is Ai Bi, and here the output is Ci plus 1 is equal to, we have Ai plus Bi. First I will take this, that is Ai Pi plus, so here we have the input to this is Ci, and we have another input for this is Ai X or Bi. Both will be added here, so I have written here plus. So now let me concentrate on this truth table. Here we can observe that in this truth table, when both the inputs are high, that is when A is high and B is high, it produces carry as 1. It produces the carry. Similarly, here also we can see when both are 1, 1, it produces the carry. Here Ci is nothing but carry input. So here it produces the carry which is independent or without using Ci. So we can observe that when both the inputs are high, that is Ai and Bi are high, definitely it will produce the carry. So I can say Ai and Bi is nothing but carry generate. So I can call Ai Bi is nothing but carry generate. I will represent this by Gi. That is Gi is equal to carry generate, because it will generate the carry. It will generate the carry when Ai and Bi are high. So similarly, here we can observe one more thing. When A is 1 and B is 0, or here also we have A is 1 and B is 0, here we can observe that the Ci plus 1, that is nothing but Ci. See here, both are same. Here also both are same. So when Ai is 1 and Bi is 1, the carry output of this XOR gate will be 1. The carry output of this XOR gate will be 1. That 1 will move here. So the same thing Ci will be connected here. So this Ci value will be represented as Ci plus 1, because if Ci is 0, 1 into 0 will become 0. So it will become Ci plus, the output of this will become 0. Similarly, if Ci is 1 here, then also this will become 1 and the output of Ci plus 1 will become 1. So now here we can observe that if this bit is 1, then only the Ci plus 1 will be equal to Ci. If this is 0, then definitely if this is 1, it will not get the output as Ci plus, output as 1 in Ci plus 1. So we can say that if Ai plus Ai XOR Bi function is 1, then only Ci will be propagated to the Ci plus 1. That is, the next stage output will be same as the previous stage output only when Ai and Bi values are different. So for this function, we can call it as it is responsible for to propagate the carry from one stage to another stage. So we will call it as carry propagate, or we can represent it as Pi. Therefore here we can write Pi is nothing but carry propagate. Similarly, here also we can observe when any one of the bit is 1, the C out is nothing but Ci. We have got the same thing. So here XOR function is responsible for propagating carry, because Ci plus 1 is same as Ci. It happens only when XOR function value is 1. So when Ai plus Bi is equal to 1, then only it will propagate the carry. So now I can rewrite this Ci plus 1 as, therefore I can write Ci plus 1 is equal to, we have Gi plus Ci into Pi. That is, we have Gi plus Ci into Pi. So now here, if we consider Ai, Bi are the inputs and Ci is previous carry. If we consider I is equal to 1 first, then we can get it as C2 will be equal to, we have G1 plus, because we have taken I equal to 1, we have C1 and we have P1. So here we can observe that the very first carry C1 will be 0. That is, very first carry is nothing but Ci in. So here the very first carry C1 will be 0. If both the inputs are 1, then definitely C2 will become 1. That is carry generate. If G1 is equal to 1, so G1 is 1 when A and Bi are 1. Therefore, here the next carry C2 will be generated without the help of C1. Similarly, if we take I equal to 2, in that case I can write it as C3 is equal to, here we have G2 plus here we have C2 into P2, or this I can represent it as G2 plus C2 is nothing but this equation, G1 plus C1 P1. So I will substitute that. So C2 is nothing but G1 plus C1 P1 into we have P2. So simplifying this, I can write it as this is nothing but G2 plus we have G1 P2 plus we have C1 P1 P2. So here also we can observe that. So this is I can call this as C2, and this is nothing but C3. So this is C3. So here in C3 we can observe that, as I said, C1 will be the very first carry, it will be 0. So again carry C3 is generated without the help of previous carry, that is without the help of C2 or C1. So here the next stage carry are independent of previous carry. So similarly, if I take I is equal to 3, so in that case I can write C4 is equal to we have G3 plus we have C3 P3, that is C3 and P3. So I can rewrite this as G3 plus C3 is nothing but this entire equation. Let me write that entire equation, that is G2 plus G1 P2 plus C1 P1 P2, and we have C3. It is, sorry, this is P3. We have P3 here, P3, or I can write C4 is equal to G3 plus G2 P3, G2 P3 plus we have G1 P2 P3, G1 P2 P3 plus we have C1 P1 P2 P3. So this is C4. So if we consider 4 stage, that is 4-bit adder, then we have only 4 outputs. That is, we have this one, we have considered it as C1. So output of this will be C2, output of this will be C3, output of this will be C4, and the last stage output will produce the carry C5. So here we can observe that C2, C3 and C4 are generated without the help of previous carry. Therefore, it will generate all the carries, that is carry look ahead adder generate all the carries before sum is produced or before some result is produced. So here in this carry outputs we can observe that here the C2, now let me compare the same thing here. C2, to generate C2, this circuit should receive C1. So but here we can see that C2 will be equal to G1 plus C1 P1. So here the initial carry will be always 0. So it is C2 is not dependent on C1 because C1 is 0. Similarly here also we can observe that C3 is equal to, so here in this term there is nowhere C2 but there is a C1. C1 is initial carry which is will be 0. So it is independent of previous carry. Similarly here also C4 is independent of either C3 or C2 or C1 because C1 is anyhow 0. Therefore this carry look ahead adder will generate the carry before sum is generated. Therefore it will generate the result very fast. Now let me draw the circuit or logic for this carry look ahead adder. Let me draw C2, C3 and C4 circuit first. That is, we have C2 is equal to G1 plus C1 P1. So let me call this is C1, G1 P1, G2 P2, G3 and P3. So let me implement C2 first. C2 is nothing but G1 plus C1 P1 plus C1 P1. Let me draw C1. So this is C1. Connect C1 and P1. This is P1. So output of this is C1 P1. So here we have plus G1. So plus means we have to use on OR gate. Let me use on OR gate. The output of this connected here. We have plus G1. So this is G1. Let me connect G1 to this OR gate. The output of this will be we have C2. So C2 is implemented. Now C3 is equal to G2 plus G1 P1 plus C1 P1 P2. Let me implement G1 and P2 first. So G1 P2, let me use this AND gate, G1 P2. So G1 is, here we have G1 line, we have G1 P2, this is P2, and another term we have C1 P1 P2, C1 P1 P2. So C1 is this one, this is C1, this is P1, and we have P2. So now this term and G2 will be added together. So let me take one OR gate again, 3 input OR gate. The input for this is this one, and we have this one, and we have G2. So let me take G2 input. So this is G2, this is one more input to the OR gate. So output of this will be, we have C3. Next, let me implement C4. So for C4 we have G2 P3, we have G2 P3, this is G2, we have P3. So G2 P3 is done. Then we have G1 P2 P3, that is G1 P2 P3, G1 P2 P3. So this is G1 is here, we have G1 P2 P3, this is P2, and we have P3, G1 P2 P3. Then we have C1 P1 P2 P3, that is C1 P1 P2 P3. So this is C1, we have P1, we have P2 and P3. So all these are connected to 4 input OR gate. The output of this is connected here, output of this is connected here, output of this is connected here. Then we have one more input, that is G3. So let me take G3, this is G3, connect this input to the OR gate. So output of this will be C4. So this is the carry look ahead adder logic circuit, that is CLA logic circuit. So now let me draw the complete logic circuit of carry look ahead adder. Carry look ahead generator. So let me assume A1, A2, A3 and A4 are inputs. Similarly, B1, B2, B3 and B4 are inputs. C1 is initial carry. C2, C3 and C4, C5 are the final carry. That is, now I will explain how to do the connection for 4-bit carry look ahead generator. So this is designed for 4-bit. I can write here 4-bit carry look ahead logic circuit. So now we'll assume that we are going to add two numbers. Say this is the given number. We need to add, we have 4 bits and here we have 4 bits. So I will consider the first bits as A1, B1. So I need, this is A1, this is B1. So according to our this circuit, so this circuit will take 1 bit for one circuit. So likewise we need 4 circuits here. So when A1 and B1 we consider, it will generate P1 and G1. So let me write P1 and G1. So this XOR output will be P1, that is carry propagator, and this is carry generator, that is G1. So similarly here we can observe P1 goes to one of the input of XOR gate, and another input for XOR gate is carry input, and the output of XOR is SI, that is sum. So now comparing with this circuit, so one of the input for XOR gate is P1, another input is carry input. So the first carry input is C1. So we must use C1, which is given to here, that is C1, as well as it should be connected to, it is connected to one of the input of the XOR gate. The output of XOR gate is S1. So now similarly, to add the second bits, that is 0 and 1, we will consider this circuit. The input is A2 and B2. It will produce P2 and it will produce carry generator G2 and it will generate C2. So C2 will be generated by using this circuit. So this circuit is already, we assume that it is presented in this block. So it will generate the C2. So one of the input for the XOR gate here, XOR gate is one is P2, another one is carry input. So here in this circuit, the carry input for this is C2, another input is P2. So likewise, to add the third bit, we use this, that is, this is A3, this is B3, output of this is P3, this is G3. One of the input for this is P3 itself, that is P3, another input is carry input. Here the carry is C3. So C3 is nothing but this entire circuit, this C3 generator. Similarly, here we have fourth input A4 and B4. So for this it is C4, here it will be P4, it will generate. So here the sum will be S2, S3 and S4. So after adding this, the fifth carry will be generated, that is C5. So this will be C5, it will be generated. This is C5 is nothing but final carry out. C out, that is nothing but C5, final carry out. So this is the complete circuit diagram for 4-bit ripple carry adder. So if this can be extended for any number of bits for the addition. Thank you for watching.